Scalars and vectors. Here we have a toy car on a box. What will happen if we exert a force on the car? Well, a force here won't do much. A force here will push the car forwards, and a force here will push it back. A stronger force would have a bigger effect. Clearly, with a force we need to know the size, or magnitude, and the direction. Here we have a cell, which is a store of energy. It makes no sense to give a direction to the energy. Energy has magnitude but not direction. Quantities that are completely described with a magnitude, which is a number and a unit, are called scalars. Quantities that also need a specified direction to be complete are called vectors. You might not have covered all these quantities yet, but we're just going to sort them into scalars and vectors. Mass is a scalar. Energy is a scalar. Power, time, temperature are all scalars. Momentum is a vector. Speed is a scalar. Force, we've already met, is a vector. Displacement is a vector, as is velocity. Distance is a scalar. Weight is a force, so it's a vector, and acceleration is a vector. It can help to say a direction after the quantity. If it makes sense, it is probably a vector. If not, it is probably a scalar. For example, 2 litres due south just doesn't make any sense, as volume is a scalar. This doesn't work for speed, which is a scalar, and velocity, a vector, which is simply speed in a given direction. But the first letters help you to remember. S for speed, S for scalar, V for velocity, V for vector. A little harder with distance, which is a scalar, and displacement, which is a vector, being the distance in a given direction. The distance you've travelled in your lifetime increases every time you move, but if you're currently just 5 kilometres south of your place of birth, over your lifetime you have a displacement of 5 kilometres south. We can represent vectors with an arrow, with length representing the magnitude, and the arrow points in the direction of the vector. You'll be familiar with drawing forces like this at Key Stage 3. Here we have a box with a 4 Newton to the right force. Here we have a 2 newtons to the left and 4 newtons to the right. So the 2 newtons arrow is half the length of the 4 newtons arrow.